So, the next lecture on the series on cloud computing for Internet of Things is on the service models. So, we briefly in the previous lecture have gone through the different types of service models. We have seen that there are three core service models that have been popular since the inception of cloud computing. The first one is software as a service, the second one is platform as a service, and the third one is infrastructure as a service. So, let us try to go through the details further of each of these cloud models. So, as we can see over here, we have these different applications which have to be served, and for serving these applications we need to take help of the software resources, the platform and the infrastructure. So, what we have software as a service, we have platform as a service, and we have the infrastructure as a service. So, infrastructure as a service on top of virtual machines, virtual storage and virtual grid. So, we have this infrastructure as a service made available, and then we have this platform as a service which includes security identification, integration workflow, application grid, user interface services, database grid and so on. And then we have this software as a service which is serving different applications as well. In fact, all these service models are serving different applications, are serving different customers and so on. And then we have these administrative services which are in addition. So, these administrative services include things like packaging, configuration, deployment, scaling, lifecycle management, utilization, user management and so on. So, when we compare these three service models, the software as a service, the platform as a service and the infrastructure as a service with respect to the traditional computing paradigm, then we observe a few things. So, whereas traditionally starting from applications, data, runtime, middleware, operating system, virtualization, service offerings, storage, networking, all these things would have to be done by the user himself. In the case of infrastructure as a service, concerns about or issues of applications, data, runtime, middleware and operating system are done at the user end, whereas virtualization, server, storage, networking are taken care of by the service provider. So, as you can see over here, in this model the operating system is at the user end. In the platform as a service, as we can see, compared to infrastructure as a service where the OS was as part of the user, here only two things, applications and data are taken care of by the user, the rest of the other things are taken care of by the service provider end. And in software as a service, everything is taken care of by the service provider. So, this is a side by side comparison between infrastructure as a service, platform as a service, software as a service and the traditional computing methodology. So, we start with each of these service models and try to understand what is inside. So, as per the definition of Amazon, infrastructure as a service, which is abbreviated as IaaS, contains the basic building blocks for cloud IT and typically provide access to networking features, computers which are virtual or dedicated hardware and data storage space. So, we have this computing infrastructure which has to be made available on demand to the different users through some kind of virtualization mechanism. So, infrastructure as a service provides the following features. It has servers for computation and the different machines are also made available like different workstations etc. So, servers and machines, then we have the storage, we have network, we have the operating system. The working methodology is like this: we have a physical server and then we have this virtualized server. The users rent the servers, the software and the data center space or network equipment. The cloud service provider offers the resource management and the outsourced service on demand is made available for use. So, this is the physical server. Here we have the hardware, on top of that, on top of hardware we have the OS and the apps, And in comparison, in the virtualized server we have hardware as before, then we have some virtual machines. So, these virtual machines VM1 and VM2 would include the operating system and the application layers. So, we have on top of the hardware multiple virtual machines executing, and there is the concept of hypervisor, which basically manages this show by sitting between the hardware layer and the VM layer. So, the VM layer basically contains the VMs, the hardware layer the actual physical hardware, and the hypervisor is sort of playing some kind of a managerial role in between these two. So, why do we need infrastructure as a service? So, basically new businesses can kickstart without basically having to invest on buying computing hardware, and this is a scalable model by which rapidly whenever the businesses need some resources, they can subscribe, pay for and start using the resources, and whenever they do not require, they will not waste the resources and will stop utilizing them. So, it is suitable for serving fluctuating computing demands, example Flipkart, Amazon etc. during festive seasons. They need more infrastructure during festive seasons because of the obviousness due to the upsurge in the business. So, but at the other times of the year they do not need this. So, as you can see that there is fluctuating computing demand, and whenever required you use those resources, whenever not required you release the resources and so on. So, it is suitable for new business model trials, it helps in minimizing the capital expenses. Scalability issue and elasticity, dynamic scaling of required infrastructure resources is made possible through infrastructure as a service. Having large amount of resource allocation or release in a short span of time is possible in the infrastructure as a service model, and there is no variation in system performance while scaling up or down. Manageability and interoperability, clients in this particular model have total control of the virtualized infrastructure resources, they can do whatever they want with the resources that are offered to them. So, they can pre-configure the facility for the allocation or can virtualize the resources, and these virtualized resources are to be monitored for their running status, the overall health and so on, and the usage and the billing system records the use of the infrastructure resources and accordingly calculates the payment. Availability and reliability, so storing of the data and the retrieval of the stored data can be made possible at any time without any failure of any kind whatsoever be the failure. So, it is not possible, the resources can be made available reliably and be made available at any time anywhere. The client should be able to access the computational resources without failure, and there should be uninterrupted facility for computation and communication. In terms of performance and optimization, high utilization of physical resources among the different clients is possible through the use of the infrastructure as a service model. It is also possible to enable high computing power with the large pool of physical resources using parallel processing, and it is also possible to optimize the deployment of physical resources by dynamically configuring the virtual infrastructure resources. In terms of accessibility and portability, this basically provides the facility for client to ease out various tasks with respect to control, management, access, infrastructure access and so on, and to facilitate the easy reallocation and duplication of the allocated infrastructure resources. IaaS can be obtained as a public cloud, a private cloud and the hybrid cloud, and each of these we have already discussed in the fundamentals lecture on cloud computing for IoT. So, the challenges and limitations of infrastructure as a service includes that there is sometimes in certain places regulatory approval that is required for the use of outsourced storage and outsourced processing through the cloud model, and network latency may degrade the level of expected performance as well. Users may require automated decision making of job scheduling to available resources and seamless scaling of services independent of traffic variation, and developers have to focus on low level system details. These are some of these limitations of infrastructure as a service. Next comes the platform as a service. So, here I will read out the definition for you. Platform as a service removes the need for organizations to manage the underlying infrastructure, which is usually a hardware and operating system combination, and allows you to focus on the deployment and management of your application. So, as you can understand, application development firms would be strongly benefited through the use of platform as a service. So, platform as a service provides the platform which allows the developers to create applications which can be offered as services via the internet. It basically makes the applications easy to develop. It simplifies the application development and deployment by providing the cloud aware features. Platform as a service is an application middleware which is offered as a service to the developers. It provides the abstraction and security for the developed applications. It facilitates the development and management applications without the complexity of maintaining the underlying infrastructure. It allows customers to rent the virtualized servers and the associated services, and provides elastic scaling of the user's deployed application. There are different features of platform as a service in terms of operating system. Operating system can be made available through the platform as a service based on the choice of the developers or the users. Server side scripting is possible, database management is possible, server software support, storage, network access, offering different tools for design and development of software, and hosting. These are all made available as different features of platform as a service. The working model is like this, that it allows the users to create the software applications using offered tools, and it provides the pre-configured features that the customers can subscribe. It supports the supports availability and management of the infrastructure and applications for customers, and the services are regularly updated with new features. The business advantages are with respect to the middleware service support, the development and deployment tools, the easy access to them, and also the freedom for managing development and deployment tools individually. And finally, the software as a service, again the Amazon definition I will read out. Software as a service provides you with a completed product that is run and managed by the service provider. In most cases, people referring to software as a service are referring to end user applications. So, SaaS is a simplified model of software delivery over the internet. It typically uses web browser working as a thin client and supports a fully pay as you go model. It also has some additional features. For example, remote access of software is possible via the internet, where the web browser acts as a thin client. It also has facilities for access and control of commercial software via the internet, and also this multi-tenancy application delivery to multiple people at the same time, multiple tenants at the same time in one to many model is made possible through software as a service. Compared to the traditional software, the comparison with software as a service is given in this particular table. The advantages include, for example, with respect to traditional software, customers have to traditionally install, manage and maintain the software, whereas in software as a service the customers simply use all these over the internet. The traditional software runs on individual organization on dedicated instantiation, whereas software as a service runs on multiple customers simultaneously. Cross platform support is required in traditional software, whereas in software as a service there is no concern for cross platform support. Like this, there are different other advantages of software as a service over the traditional software. Scalability is to maximize the application concurrency, to optimize the shared resource pool such as threads and network connections. Multi-tenancy It's an important architectural shift from designing isolated single tenant applications to supporting multiple tenant applications. It has the ability to accommodate users from multiple companies at the same time, and there is transparency that is improved by the use of this model amongst all the users. In terms of configurability, it is about to facilitate it facilitates parallel allocation of single application on a single server to several users, to customize the application for one customer while changing the application for other customers as well. The limitations of SaaS include supporting centralized control, so that is not a very good thing, it is a limitation. Switching the cost, so switching cost between different software, limited flexibility, it has limited flexibility, and there are data security and privacy concerns in this model. So, these are the three main models of cloud: the software as a service, platform as a service, and infrastructure as a service, and we have gone through the different advantages and limitations of each of these models. And as you will see later on, that these models coupled with few other concepts are required in order to meaningfully develop and deploy IoT services, maybe for smart home applications or maybe for smart cities applications. Thank you.